This conference will now be recorded. This conference will now be recorded. This conference will now be recorded.
So, good afternoon, students. Today we are starting discussions on the problems from IIT JEE advanced papers. So this will be done in the chapter wise manner. So today I have again started with the first two chapters, electrostatics. So we'll pick up questions from JEE advanced papers on this particular chapter and try to complete from all the way from 2013 to 2022 step by step. Okay, first let us uh, concentrate on today's problems. So the first problem says two non-conducting spheres excuse me, two non-conducting spheres of radius r1 and r2 and carrying uniform volume charge densities plus rho and minus rho respectively are placed such that they partially overlap as shown in the figure. This is the figure. So we have two spheres, solid non-conducting spheres having radii r1 and r2 and charge densities, volume charge densities plus rho and minus rho. So this is negatively charged and this is positively charged. Anyway, the charge densities are same. So now the question is, what happens in this overlap region? There are four options. At all points in the overlapping region, the electrostatic field is 0, the electrostatic potential is 0, the electrostatic field is constant in magnitude, electrostatic field has the same direction. So this is the question we have to answer. So let us consider this figure. So these are radii r1 and r2, and see, let us consider this particular triangle P, C1 and C2, this particular triangle, and here I'm just considering the position vector of this P with respect to the centers C1 and C2 of the spheres. This is R1, position vector R1, and let us say it is in this way. Okay, so position vector with respect to C1 is R1 for the point P, and the position vector of the point P with respect to C2 is R2. Okay, small r2. Now let us say this C1 C2, so I'll just write it. So C1P, this vector is R1 vector, then this C2 C2P vector sorry, this is there is a loose connection in the tab. Okay, now it has come. So C2P is vector R2, and let us say this C1 and C2, this vector which is D vector, and it is R1 minus R1 minus R2. R2. That means it is in the direction from C1 to, it is directing from C1 to C2. Now look, we just want to calculate electric field at point P. We just want to calculate electric field at point P due to this positive rho and due to negative rho. Anyway, since this is a sphere and non-conducting sphere, we just think that the whole charge is concentrated at the point C1 and C2 for both the spheres. So we can just consider that the whole charge is concentrated at C1. So if we just want to calculate electric field for the charge plus rho, I'm writing just E1 for that. Okay, at P, E1 at P. Okay, so how do we write E1? Since it is a point charge, we can just write like Q by 4 pi epsilon naught R1 square. If I want to write in terms of vector, so it will be R cube R1 vector. Okay, now this Q can be written that it can be written as 4 by 3 pi this charge. Actually, see, it can be written as 4 by 3 pi R1 cube into rho, positive rho. Okay, so the charge which is enclosed by this particular sphere, all right, so we can then write here, it is 4 pi epsilon naught R1 cube, this is R1 vector. Actually this charge is the charge which is enclosed by the sphere, having radius R1. Okay, so this much is the charge which is going to produce a field at P. Okay, then I can write this as 4 pi will get cancelled, so it will be rho by 3 epsilon naught, and this is R1 vector. Okay, now for the other case, also, since this are actually symmetric, if you see the C1 and C2, they are symmetrically situated at this positions, so we can write for E2 electric field produced by the other sphere at P will be similarly minus rho by 3 epsilon naught into R2 vector. Okay, due to this minus, right? So electric field will have direction in this way. Okay, minus R2 direction. All right, this will have direction E to this way, and E1 has direction in this way. Okay, so the resultant will be actually in this way, parallel to this direction. Okay, so if we just take the resultant at that point, so the resultant electric field at P will be sum of vector sum of this two fields. Okay, so which will give you actually rho by 3 epsilon naught R1 minus R2. Okay, so this is nothing but rho by 3 epsilon naught into D vector. So which is a constant quantity, because D is constant, epsilon naught is constant, rho is also constant. So this electric field at P is a constant quantity. Therefore, we can choose the option C, the electrostatic field is constant in magnitude. So that is what we can choose from here. Okay, so the electric potential is not zero. It's zero. It is not true. Electrostatic field is zero. This is also not true. Electrostatic field has the same direction. Now this is also not true. So only this one is the correct answer for this question. Okay, so now let us go to the next question. This question says a parallel plate capacitor has a dielectric slab of dielectric constant K between its plate that covers 1/3 of the area of its area, 1/3 of the area of its plate. As you see here, this is, suppose the whole area is A, this is 1/3, that is A by 3. So a parallel plate capacitor has a dielectric slab or dielectric constant. So this is dielectric slab which is a dielectric constant K between its plate that covers 1/3 of the area of its plate. So this part is covered with dielectric material having dielectric constant K. The total capacitance of the capacitor, so total capacitance of the capacitor C, total capacitance, okay, total capacitance is C. That means the part which is having dielectric material and the part which doesn't have any dielectric medium, or it is air in between these two. Okay, in this region. Okay, air in this region, and here dielectric material of dielectric constant K is placed. Okay, so this total, that means the total, if I say capacitance for this part is C1 and this part for C2, then actually total capacitance of this is C actually. Okay, we have to find out. Okay, so the total capacitance of the capacitor is C, while that of the portion with the dielectric in between is C1. So this one has capacitance C1. Okay, this part has capacitance C1. C1. When the capacitor is charged, the plate area covered by the dielectric gets charged Q1, so it gets charged Q1, and the rest of the area gets to charge Q2, as you see here. The dielectric field in the dielectric is E1, and that in the other portion is E2. Choose the correct option or option. So maybe there may be more than one option. Ignoring the edge effect. Edge means there will be fringe field, so we don't need to consider the fringe field effect. So this is 2a/3, this portion. Okay. So it is very simple to solve this question. How? We know if I have a parallel plate capacitor. Okay, let me just summarize the problem itself once again from this figure. So this is a parallel plate capacitor, as you see. 1/3 of the area has been like a dielectric material of dielectric constant K has been placed. So this is slab of dielectric constant which is placed inside the plate of the capacitor, which covers A/3. That means 1/3 of the area of the plates, and 2/3 is actually contains air only, air or vacuum. Okay, this is air capacitor. This part is air capacitor. This is a capacitor which has a dielectric slab of dielectric constant K. Okay, now when it is charged, it is seen that this portion is gets charged by Q1, and this rest of the portion is getting charged by Q2. Okay, now if the electric field of this particular portion or in the dielectric is E1, and rest of the portion has got electric field E2, then which of the following options are true? Whether E1 by E2 is 1, E1 by E2 is 1 by K, Q1 by Q2 is 3 by K, C by C1 is, C means total capacitance and C1 is the capacitance of this portion which has dielectric slab. That ratio is 2 plus K by K. So we have to find out the answer for this. So first of all, let us see this particular parallel plate capacitor, how we can think like how, see, there is a clear one thing is very clear, that there are two capacitors, one is C1, another one is C2. And see, this C1 and C2, if I say this is C1, C2 and this is C1, they are actually under the same potential difference. Okay, they are in the same potential difference. So look, I can just equivalently consider this kind of circuit for this particular capacitor here. Okay, so while charging, see this, since this part and this part both are actually having the same potential difference, within the same potential difference, so we can say that this, if I say this is capacitor C1 having capacitance C1, another one is the capacitor having capacitance C2, then these two are actually parallel combination. They are in parallel combination. So what we can say? We can say C1 plus C2 is the total capacitance C. That we say. Now what is C1? C1 is actually capacitance of this dielectric, like of this particular portion, which is dielectric slab of dielectric constant K. So we know when a parallel plate capacitor is actually placed with, or the place or the in okay, so if we have a parallel plate capacitor, each plate has area A, and if a dielectric slab of thickness D and area A is placed, see if this is the dielectric slab having dielectric constant K, okay, then the capacitance will be epsilon naught into K, dielectric constant, A by the distance between the plates. Let's say that is D. So this portion has capacitance C1 is equal to epsilon 0 Ka by D, right? But this A is not A here, A is A by 3. So I'll write A by 3. Therefore, we have capacitance for this particular portion as epsilon 0 Ka by 3D. Okay, this is C1. Let us say this is equation 1. And what is C2? C2 is just epsilon 0 A is the area, this area now 2A by 3, epsilon 0 2A by 3 divided by D. That means 2 epsilon 0 A by 3D. Okay, this is the capacitance C2. Then what is C? C will be then C1 plus C2. This is equation 2, say C2 plus C1 will give you, see this is 2 plus K, and it will be A by, sorry, A epsilon 0 by 3D. Okay, this is the one. Okay, A epsilon 0 or epsilon 0 A by 3D into 2 plus K. So this is the capacitance C, right? So what we have got, I'll write once again, clearing everything. C1 we have got epsilon 0 Ka by 3D, epsilon, sorry, C2 we have got epsilon 0 A by, here 2 will be there, 2 here 3D down. Okay, and then C we have got epsilon 0 A by 3D whole into 2 plus K, right? So now there is an option C here, C by C1. Let us see what is C by C1. C by C1 is, or C1 by C. Okay, C by C1. So C by C1, C is this one, epsilon 0 A by 3D. And what is C1? C1 is this. So 3D will go up divided by epsilon 0 Ka. So this will be cancelled from both numerator and denominator. So you'll get 2 plus K by K. So this is actually correct answer. So this is correct answer. Now look here, we have got Q1 by Q2 is equal to 3 by 2. See, since C1 is 2 epsilon 0 A by 3D and C2 is epsilon 0 Ka by 3D. So what will be the charge? Because see, both of them are actually are having the same potential. Okay, same potential, so they are actually charged with the same potential difference. Okay, so then we know Q is equal to CV. So Q1 by Q2 will be C1V by C2V. VV goes up, then we should get C1 by C2. So what is C1 and what is C2 we know here. Okay, so it will be actually C1 by C2 will be actually 2:1 or only 2. Okay, it will be 2, sorry, 2 by K, 2 by K, not 3 by K. So this is not true, it will be 2 by K. Okay, this is not true. Now let us go to the electric field. So what is electric field? How do you find out electric field? So electric field, we know in this case, since, say, electric field we know it will be given by potential difference by the distance. Okay, potential difference by the distance. Look here, both of them are having the same potential difference. Okay, and the plates have the same distance. Okay, same distance. Therefore, E1 and E2 both will be the same actually. This is electric field V by D. V is the potential difference between the plates, and D both are actually same for both the capacitors C1 and C2. So U1 by E2 will be another correct answer. Okay, so this is the one. So this is not the true. Okay, so we have got two answers correct. One is A, another one is D. So these two options are correct option. So what are the correct options? Correct options are A and D. So now we have third problem. This problem is also very interesting problem. Let us see. Let us first read the question. The question says E1, let E1 R, that means the electric field is R means electric field is function of distance or position vector. E1 R, E2 R and E3 R be respectively the electric fields at a distance R from a point charge Q. That means electric field E1 is created by a point charge Q at a distance R. Okay, R. All right. So this is electric field produced by a point charge E1. Then E2, that is the electric field produced at some point R by an infinitely long wire. So if I have an infinitely long wire, then it produces electric field at R distance, that is actually E2R. Then E3R is the electric field produced at some point R due to an infinite plane with uniform surface charge density sigma. That means E3 is produced by an infinite plane having charge density sigma. Okay, having charge density sigma. Infinite plane means both the directions. Plane has two dimensions, so both the directions will be infinity. So then it is, so if this is x and this is y, both the directions are actually going to infinity. So that is actually infinite plane surface having uniform charge density sigma. And if I just find out electric field at r distance at any point r from the surface charge density, so from the infinitely long wire, so this is the electric field produced by E3R is the electric field produced by such infinite plane. Okay, now so charge density for this infinitely long wire is lambda. This is linear charge density, that means Q by L. If L is the length, finite, in case of finite length, at least you can say lambda is equal to Q by L. Okay. Anyway, for our discussion purpose, we will take lambda, charge per unit length, instead of taking the whole length for the charge. Sorry, for calculating charges. Yes. Now the question is, that if E1 R0 equal to E2 R0 is equal to E3 R0 at a given distance R0, then the options are A is Q is equal to 4 pi sigma R naught square. First option. Second option says it is R0 is equal to lambda by 2 pi sigma. Option C says that E1 R0 by 2 is equal to 2 into E2 R0 by 2, and option D says it is E2 R0 by 2 equal to 4 R3 4 E3 R0 by 2. Okay, so we can do one thing. We know the form of the electric field produced by plane charge, like say E3 R will be actually sigma by 2 epsilon 0 at any distance. Okay, similarly for E2 R, it is actually 2 lambda. It is the electric field produced by line charge 2 lambda 4 pi epsilon naught uh, 4 pi epsilon naught R. Okay, 4 pi epsilon naught R for line charge, and for point charge we know all that this is Q by 4 pi epsilon naught R square. Okay, these are the expressions, general expressions for electric fields for various symmetries, like see point charge, which is spherical symmetry, the plane symmetry, planar symmetry. It doesn't directly depend on the distance, because for infinitely plane charge, electric field at any point at any distance will be the same, that is sigma by 2 epsilon 0. An electric field produced by an infinitely long charge having charge density lambda is given by 2 lambda by 4 pi epsilon naught R. Now look, it is given that E1 R0 equal to E2 R0 equal to E3 R0 at certain distance R0, all of them are equal to each other. So what we can do is we can just actually see, we can just write this to find out some unknown parameters. Let us see. So this E1 is for point charge, right? Q by 4 pi epsilon naught R0 square we can write, and this we can write E2 is for line charge, so we can write 2 lambda by, okay, we are just writing E3 and E1, and we will try to find out something from there. So E3 is actually sigma by 2 epsilon 0. So epsilon goes off from both sides. Okay. So if we require something from here, we can find out. Okay. Okay. Suppose this is okay. Then it goes like this. Q by 4 pi 4 pi will become 2 pi actually. It goes 2 pi. So let me see the options. One option is Q. Okay, we'll see whether we get Q like that. from here. Okay, let us find out the Q from here. So what is Q then? Q is, see, it is becoming 2 pi sigma r0 square. Okay, let us see. So this is actually 4 pi sigma r0 square. So that's why it is not correct. Okay, Q we have found out and we see that is not true. Okay, now we see another option. Their r0 they have calculated in terms of lambda and sigma. So let us see if we just, so this is the one part, and first part, second part, let us see if I just equate this two, then what I get. I can write this as 2 lambda by 4 pi epsilon naught r naught, and here E3 is sigma by 2 epsilon 0, there is no change at all. So from here we have to find out what is R0. Let us say, okay, let us calculate this R0. What is R0? R0 is, see, I'll just take this here in place of sigma, and rest of the things I'll just bring here and there. Okay, so 2 lambda, 2 sigma will be multiplied divided by 4 pi epsilon naught and sigma. Okay, now look, this is 4 goes off and sigma goes up, so we get actually lambda divided by pi sigma. R0 is equal to lambda divided by pi sigma. Let us see whether it is there. So so R0 is equal to lambda divided by 2 pi sigma. It says here, it is said 2 pi sigma, but we have got pi sigma. So this is also not correct. So this is also not correct. This is also not correct. So R0 is equal to pi sigma we are getting, but it is given as 2 pi sigma, so it is not correct. So lambda, sorry, R0 we had got lambda by pi sigma. So which is not correct equal to the given option. Okay, that means this given option is not correct. Our calculation is correct. Now we will be finding out E1 R0 by 2 and E2 R0 by 3, R0 by 2 and E3 R0 by 2. Okay, so okay, so let us see E E2 0 by E2 R0 by 2. So what is this E2 R0 by 2? E2 R0 by 2, E2 was 2 lambda by 4 pi epsilon naught, that part, right? So it is for line charge, 2 lambda by 4 pi epsilon naught R0 by 2 we have to write here. So what we get is 4 lambda by 4 pi epsilon naught, 4 pi epsilon naught R0. Okay, 4 goes up, so we get lambda by pi epsilon naught R0. So this is, suppose, option 3, or sorry, this not option 3, this is equation number, let us say equation number 1. Okay, E1 also we can find out, E3 also we can find out, we can, let us say, R0 by 2. So this is always the same, 2 sigma by epsilon 0. And what is E1? E1 is Q by 4 pi epsilon naught R0 square. Okay, so this is the thing. Now if it is, sorry, this is R0 by 2, I have to find out R0 by 2. I have to write for R0 by 2. So R0 by 2 means 4 will be in the numerator divided by 4 pi epsilon naught R0. Okay, 4 goes off, so Q by q by epsilon naught q by pi epsilon naught r0. Now, okay, we'll see the options. Option says this E1 and E2. We'll see what is the relation between E1 and E2. So relation between E1 and E2. E1 and E2. If we place, okay, let us write E1 over E2. So E1 is q by 4 q by, this is actually r0 by 2, and this is also r0 by 2. I'm taking the ratio of these two. So q by this will be pi epsilon naught r0 lambda and divided by lambda. Okay, these are actually same for both. Oh no, this is r0 square. So there will be r0 square here. So one r0 will be there. Okay, one r0 will be there. Let us write that then. So we have got r0 into lambda. So in the options, we have to find out what is the relation between E1 and E2. Let us see. We have not come to any conclusion so far. So if I just write this R0 in terms of lambda and sigma, if I write in terms of, and also we had Q is equal to this much. Okay, Q is equal to 2 pi sigma epsilon naught square, sorry, r naught square. If I write that 2 pi sigma, look, I am just writing from here 2 pi sigma r naught square, that we had already found out. 2 pi sigma r naught square, 2 pi sigma r naught square for q, and this is r naught. And let us write what is r0 in terms of lambda and sigma. Okay, so if we write up to at least up to here, we have got 2 pi, let it be there, and we have 1 r naught gets cancelled. So 2 pi sigma by lambda into r naught. If we write the value of r naught is lambda by pi sigma, r naught is lambda by pi sigma. Let us see what we have got. Lambda by pi sigma, so see pi sigma got cancelled, and this got cancelled, so it is 2. Okay, so this is 2. That means, see, therefore E1 r0 by 2 and E2 r0 by 2, these are related like this. Okay, E1 r0 by 2 is equal to E2 into r0 by 2. Okay, 2 into E2 r0 by 2. So this is the relation between E1 and E2. Okay, this is the relation between E1 and E2, and that is actually correct. So it is, this option is correct here. Okay, so the first option was not correct, second was not correct, third C is correct. Now we will see whether E2 and E3, how are they related. E2 and E3, how are they related? E2 r0 by 2, it is 2 lambda by 4 pi epsilon naught. R0 by 2 we had got 4, so 4 get cancelled, so it will be pi epsilon naught r naught. This is actually is E2 r0 by 2. Okay, E2 r0 by 2. and E3 R0 by 2 is again having the same value. E3 R0 by 2 has the same value, sigma by 2 epsilon 0. Now if I take the ratio E2 by E3, that is lambda by pi epsilon naught R naught, and here it is 2 sigma naught, sorry, 2 epsilon naught by sigma, so it is this, I'm sorry, this R0 will be there. I'll put the R0 value again. Okay, so lambda 2 lambda by pi sigma R naught. If I put the value of R naught, look, R naught is actually, see, R naught actually lambda by pi sigma. Okay, that is what we have found out. So pi sigma will go here, lambda will be here, lambda will be here. Okay, then what we are getting is this pi sigma get cancelled, lambda get cancelled. So E2 R0 by 2 is equal to 2 into E3 R0 by 2. So this relation is like this. Okay, 2 into this, that means E3 E2 is twice of E3 at position R0 by 2, but option says it is 4 E3 R0 by 2, which is not correct. Okay, then we have got option C is the only correct answer. Okay, now we'll go for one more problem. The problem says 3 identical capacitors. I'll write down the problem. This is from JEE ADV Advanced paper 2018, which we are going to solve now. It is saying that 3 identical capacitors C1, C2 and C3 have a capacitance of 1.0 microfarad. That means 1 microfarad. Each, and they are uncharged. They are uncharged. Okay, they are uncharged initially. Okay, they are uncharged initially. I'll read out later. Let me just first write the whole question itself. Okay, they are connected in a circuit. They are connected in a circuit as shown in the figure. And C1 is filled completely with a dielectric material, with a dielectric material with a dielectric material of relative permittivity with relative permittivity epsilon r. Epsilon r, dielectric material with, sorry, this is material of relative permittivity epsilon r. The electromotive force, the EMF, electromotive force V0. Okay, so actually here it is charged by cell. Electromotive force of the cell is V is equal to 8 volt. Okay, 8 volt. V0 is equal to 8 volt. First, if, okay, let me draw the figure now. See, this is the battery, then it goes like this. This is another one point. Here there is a switch, and there are two capacitors C1 and C2 in this branch. Okay, there are two capacitors C1 and C2 in this branch. This is C1 and C2, and this switch is named as S2. Okay, so there is another switch over here. So this is S1 switch, S1, and see, another capacitor is actually connected here, C3. Okay, and this is connected like this. Okay, this is V0. Okay, so this is the circuit diagram. Now it says first S1 is closed. First S1 is closed. First S1 is closed. I'm sorry, this is giving so much trouble. So it is first S1 is closed while the S2 kept open. While S2 open. Okay, I'm writing in short. When the capacitor, it is first S1 is closed, S1 is closed, and S2 was open. Okay, when the capacitor, when C3, capacitor C3 is fully charged, S1 is opened, opened, and S2 is closed simultaneously, is closed simultaneously. I hope you are understanding the problem. When all the capacitors, the question is when all the capacitors capacitors reach equilibrium, the charge on C3 is found to be 5 microcoulomb. Then you have to find out the value of epsilon r is dash. So this is a question type of like you have to find out some integer answer, that kind of question it is. So you have to find out the integer value of that epsilon r for the question. There is no options given, you have to just find out the value of epsilon r. So it is also a very simple question, we have to just little bit think. So what happens, so V0 is given already, so let us read out once again the question. So see the identical capacitors of capacitance C1, C2, C3, each having capacitance 1 microfarad each. Okay, so they are uncharged initially, and see in the figure it is shown that C1 is actually filled with C1 here, C1 is filled with some dielectric material having relative permittivity epsilon r. The electromotive force of the battery is 8 volt. Now first S1 is closed while S2 was open. Okay, S2 was open, and then when C3 is completely charged, when C3 is fully charged, sorry, when C3 is fully charged, then S1 is opened and S2 is closed. Okay, that means you know what, when the S1 was closed, S2 was open, the circuit was equivalent, we are just writing here. So when S1 closed and S2 open, then what was the situation? The situation was, the circuit was like this. Only C3 was connected to this battery, right? C3 was connected to the battery, C3, and with V0 8 volt. So in this case, sorry, this is, see when it is fully charged, then the S2 will be opened, sorry, S2 will be closed and S1 will be opened simultaneously. So that is the thing here. So this is 8 volt. Okay, if we want, we can find out the charge on this, but anyway C3 is 1 microfarad, we know that. If we require the total charge on C3, we can find out that. So how much will be the charge on C3? The charge will be actually see Q is equal to CV. So this is volt, this is microfarad, so it will be microcoulomb. So 8 microcoulomb. This will be 8 microcoulomb on C3. Okay. let us say this is Q3. Now look, when the S1 is open, okay, this is C2, this is C1, and this is C3. Actually, this will be the circuit because S1 is now open. This is S1 with battery. This was battery, right? So this is open now. That means C3, the charge of C3 will be actually charging these two guys. Okay. Since these two are actually in series, look, this has some dielectric constant, dielectric material epsilon r in this. Okay, and see, when this is in equilibrium, this C3 has charge of 5 microcoulomb, right? And see, since this is actually in series, same charge will be like this C1 and C2 will be charged with the same charge, that is 3 microcoulomb. I hope you agree with me. So in the first situation, the C3 gets charged 8 microcoulomb, and in the second situation, only the capacitors C3, sorry, C1 and C2, they are connected to C3. Now the battery is actually disconnected. That means the charge on C3 will be distributed to this C1 and C2 according to their capacitance or capacity, and it is said that after equilibrium is reached, the C3 is having capacitance 5 microcoulomb. Okay, 5 microcoulomb, right? So then the question was, what is epsilon r? What is the value of epsilon r? Now if I take the capacitance with dielectric, say this guy will have capacitance C is equal to epsilon r into Cu1, okay, with capacitance. So this will be 1 microfarad into this, so epsilon r microfarad, if I say that. Now look, if I apply loop rule, we can write 5 by 1 minus 3 by epsilon r minus 3 by 1 is equal to 0. What does it mean? See, Q we know, Q by V is equal to CV. CV is equal to Q, so V will be Q by C, right? Q by C. So Q is how much in this? Actually, this is, so now you can think of this as battery. Okay, so I have here 5 by 1. This is the voltage here, and this is actually distributed here. That means actually I can directly write 5 is equal to 3 by epsilon r, sorry, epsilon r plus 3. This is equal to 5 by 1 or 5. Okay, so this is from a loop rule. So then we get 3 by epsilon r is equal to 2. Therefore epsilon r will be 3 by 2, so it will be 1.5. So 1.5 will be the value for epsilon r. Okay, so it is 1.5. Okay, so this is the answer for this question. So it will be 1.5, and this is dimensionless quantity. Okay, so with this we'll stop it for today. We'll pick up all the advanced problem from JEE advanced paper from this electrostatic chapter. Like there are two chapters, chapter 1 and chapter 2. We'll continue to solve the questions up to 2012 and 2022, and then we'll move on to other chapters. Okay, so thank you for your patience. Bye for today.